it will be my great pleasure to introduce our first speaker of the day, NASA Deputy Administrator Jim Morhard. Jim began his career as an analyst for the Secretary of the Navy, and now at NASA supports the agency's many missions, including space exploration, earth sciences, aeronautics, and is an avid advocate for space education and outreach. Jim, welcome, welcome. It is a pleasure to introduce you this morning, sir.
Ivy, Janet, I sure appreciate your kind words beforehand. Life is pretty precious right now, and I just really appreciate what you just said. I'm going to talk a lot about what we're doing at Mars, and let me begin by, Space Policy Directive 1 calls on NASA to return to the moon with commercial and international partners, really in preparation to explore Mars. And President Trump made this happen. And, he established the Artemis program, which is going to test, refine, and perfect many of the technologies and operations that are pretty complex that'll be needed to land humans on Mars, as well as perform work there and then safely get them home. NASA's been exploring Mars for more than 50 years. I think it started in 1965. We did somewhat of a flyby, but we've had a continuous robotic presence there since 1997. And even during COVID, and yes, we will all get through COVID, we had a gentleman driving the Curiosity rover from his home. We're speaking of rovers. The Mars Perseverance rover launched a month ago, and we expect it to land February 18th of next year. It's got 7 investigations or demonstration projects on it, and it'll operate for at least 1 Martian year, which is about 687 Earth days. Perseverance's mission objectives include searching for signs of ancient microbial life. Other objectives include helping pave the way for human exploration beyond the moon and characterizing the geology and climate of Mars, as well as taking samples to leave on the surface of Mars to be picked up by another mission called Mars Sample Return. They'll then be brought back to Earth in a few years, and this is the first leg of the first round-trip adventure to another planet. Another thing that demonstration effort that's probably the most challenging is entry, descent, and landing. We call it the 7 minutes of terror. Perseverance will arrive in an atmosphere with an average temperature of minus 80 degrees Fahrenheit. It'll enter the atmosphere going 12,000 miles an hour. And Perseverance is really programmed to be autonomous at that point. It better be, because it's going to be on its own. And we're using terrain relative navigation, which has advanced algorithms and sensors, and it'll take a picture of the location it's approaching and then compare it to what's already been mapped. And it then avoids large-scale landing hazards by quickly and hopefully independently modifying its trajectory during that descent. This kind of autonomous guidance could be critical to safely landing humans there. Before this mission, rovers were sent to very safe landing sites and then drove for months sometimes to where we wanted them to go. As Perseverance's landing is landing, it'll be slowing down and deploying its parachutes all at the same time. And once it lands, we'll command the vehicle once in the morning so it gets its marching orders for the rest of the day. And it'll really decide on its own how to keep itself safe and how to execute commands it receives from Earth. For the first time, we'll have 4 what we call entry, descent, and landing cameras, and 2 microphones recording all of it, which is, I think, going to really change how we see these efforts to land on Mars. So we'll see it and we'll hear what it's like to come down into that atmosphere. All in all, we have 25 cameras on Mars Perseverance. 19 more are on the rover, some of which are for taking pictures of microscopic material, and 2 are going to be on the helicopter we call Ingenuity. And with Ingenuity, we're going to attempt the first powered flight on another planet. It has 2 coaxial 47-inch rotors, and it really looks like a box with the rotors and a little solar panel on top of it, and 4 spider legs. It really was a late addition, but the Jet Propulsion Laboratory found a way to strap it on the bottom of the rover. And Perseverance will place it on the surface and then back off about 100 meters and film it as it attempts to fly. And we really hope to fly Ingenuity up to 5 times. We hope to use such a craft as forward scouts for our astronauts, as well as a communications relay for astronauts that may be out of sight of their home base. It's really designed to provide overhead images with approximately 10 times the resolution of orbital images that we can take today. We're hoping that such scouting intelligence may enable future rovers to safely drive up to 3 times as far per day on Mars as we are today. We're going to a place called the Jezero Crater, and it's located just north of Mars' equator. And it's a crater that billions of years ago might have been a body of water about the size of Lake Tahoe. In the several Slavic languages, Jezero means lake. There we really hope to pick up samples of the soil and some rocks to put them in titanium tubes that'll be picked up by the Mars Sample Return Mission, also called MSR, that launches from Earth in 2026. And once the samples are picked up, MSR will then launch from Mars to an orbiter that will return to Earth in 2031. And keep in mind that Mars Sample Return the Mars Sample Return technologies will help us learn how to take humans off of Mars and rendezvous in orbit for a return to Earth. The doors could swing wide open on how we think about our place in the universe if we find ancient microbial life there. I'm not saying we expect to find life, but there are methane plumes there that could either be geological or biological. And there's also water 15 kilometers underneath the surface in some places. Both suggest there could be or have been life there on Mars. That's why we're so intent on going to Mars before any other planets or moons. We'll be looking for patterns and textures of geological formations that suggest biosignatures. The Pilbara outback in Australia has the oldest confirmed fossilized life forms on Earth. NASA scientists went there to study how the fossils got there and to identify nearby geologic signatures that might be signposts that we could use on Mars. The probability of finding life on another planet is going up, make no mistake. And with what we know so far, our best probability of finding it points to Mars. Now, 95% of the Martian atmosphere is carbon dioxide. Since we need to breathe up there, we hope to demonstrate how we can take oxygen molecules from carbon dioxide. We call this investigation MOXIE, which stands for Mars Oxygen In Situ Resource Utilization Experiment. It's about the size of a car battery, really, and it'll make oxygen like a tree does. It inhales carbon dioxide and then exhales oxygen. On a much larger scale, this type of technology could provide breathable oxygen and propellant to allow for future human missions. This really is a celebration of American ingenuity and perseverance. Now let me talk about the moon. Using robotics and humans, we'll explore the moon throughout this decade more than we have ever before. We'll in turn replicate a lot of what we do at the moon to safely send the first humans to Mars. We really need the moon to get us there. This is America's Moon to Mars exploration approach. This is what President Trump lit a fire under NASA to do. As global capabilities in space exploration increase, America must lead. Make no doubt about it. And will do so by landing the first woman on the moon. As with Apollo, who leads in space leads the world. We're trying to send the first humans to Mars on a 2-year journey. We hope to use advanced propulsion to limit their radiation exposure. The mission allows for 30 days on Mars. That exceeds the total time of all Apollo missions on the moon. In preparing to live and work on Mars, we'll build an Artemis base camp on the moon's south pole and test new mobility, habitation, propulsion, and landing systems. The Gateway will serve as a staging point for lunar surface activities and missions farther into the solar system. Together with the Artemis Base Camp, these sustainable exploration capabilities allow NASA to rehearse for Mars. Many of the technologies that will advance for the moon will also have direct application to human exploration of Mars. For instance, the Space Launch System and Orion spacecraft that'll send astronauts to the lunar orbit for the Artemis missions can also send Mars-bound astronauts to their Mars transit spacecraft. Commercial cargo suppliers can provide in-space refueling and logistics deliveries to outfit Mars spacecraft. Cryogenic storage solutions designed for the human landing system will benefit many key components of a Mars architecture. The human landing ascent element is anticipated to be like a Mars ascent system. Another is the pressurized and robotic Artemis rovers. They'll have significant commonality with those needed on Mars. Nuclear fission power that NASA plans to demonstrate on the moon is expected to be used at Mars. Electric propulsion thruster advancement used in the Gateway's power and propulsion element will help in the progress of a Mars propulsion system. And Gateway will mimic crew descent and ascent operations for Mars. Operational experience at the moon will support learning the safest and the most efficient way of scientifically explore Mars. It'll support automating processes and using robotics to assist and maximize human-led sciences. At both places, we hope to use local resources. We hope to find out on the moon whether we can harvest water ice for oxygen to breathe and hydrogen possibly for propellant. We also may be able to harvest metals from asteroid impacts. And with 3D printing and robotics and artificial intelligence, we may be able to use these materials to manufacture hardware. Finally, we hope to address the physical and behavioral health challenges of any crew, both at the moon and at Mars. The human system is the most complex of all the systems that we're challenged with. So we're developing many technologies for Mars and for the moon that can be applied to Mars. Now let me stop there. I've got to mention astronaut Jerry Carr, who passed away last week. In 1973, he led the final mission on the first U.S. space station, Skylab. He really was a pioneer of long-duration space flight. The men and women of NASA and its partners have always faced great odds. They've overcome enormous challenges to advance the capabilities of our nation and inspire all of us. Jerry was really very much a part of that. This year, we've overcome COVID to successfully launch Crew Dragon and Mars Perseverance. Soon, we'll light up all 4 RS-25 engines of the Space Launch System in preparation for a 2021 launch of Artemis 1. And on October 23rd, we hope to launch what we call Crew 1, which will have a crew of 4 astronauts going to the International Space Station. We hope our efforts inspire the United States and the world to come together, to stand above our differences, and to work to improve the human condition. And thanks to President Trump, we're really at the dawn of a new space age. We join with other freedom-loving countries to go to the moon. This time, it's a proving ground to prepare to go to Mars and beyond. Not because we do what no one else can, and not because we want to advantage ourselves over other countries. We do it to better the human condition of all people. And we do it to build a better life for our children and our grandchildren. Not just for Americans, but for all people on this earth who want to work together. We do it because exploration is a fundamental trait of our species. It's our shared destiny, and therefore we go together. It's a challenge we again accept and that we'll accomplish. Thank you very much.
Be a part of the space industry, and I think as I work with children from around the globe, NASA has nothing to worry about. We've got plenty of a pipeline, and future international partners abound, and they are potentially right now sitting at their desk and are 8, 9, 10, 11 years old. So I am certain that the future is not only bright for now, but as we continue on. Anything else that we need to know about what NASA is doing, or anything that you might tell a student? We've got plenty of them on the lines. Anything you want to tell them about what your path looked like, or who your biggest inspiration or mentor might have been?
Oh, gosh, Janet, thank you for the question. First off, we need more scientists, we need more engineers, we need mathematicians, but we're also going to need a lot of other fields. But honestly, we're lacking in those fields. And I just urge folks that are trying to decide where their career path is. Those are some challenging fields, there's no question. But if you have the abilities, I urge you to pursue them, because you're going to be dearly needed in the future. And, we have a service-oriented economy right now, and we really have to go back to where we were during the Apollo era. You think about mission control. The average age at mission control for Apollo was 26 years old. So it's that youth we're looking for, but you have to be prepared to do that. As far as my own path, the path on our lives is not from point A to point B. It's not straight. It is very circuitous. And Janet knows I've had a number of jobs, and many of them really weren't none of them were in the space industry. And I also was in a plane crash 10 years ago, which really changed my life. And my definition of a crisis is a little different than it was 10 years ago, which helps in this job. But with that, when they called me, the administration called me and wanted me to become the deputy administrator. I said, why? And they said, Jim, we've got scientists and engineers, but we need someone who understands how to manage large organizations, how to acquire appropriations. And those two things are something I've been doing since I was 21 years old. And hopefully you've seen what we've done. As I've said this past year, this isn't me. This is a team of dedicated people. Starts with the administrator, but it goes to all 17,000 of NASA employees and many, many more contractors and international partners and so many more people. And that's really the beauty of how NASA operates. It's really collaborative. Hopefully that answered your question, Janet.
It's okay that you are a B- in math. It's like if you have the drive, there is something out there for you to do. And if you're an artist and you can envision the things that the engineers are designing, or those architects, and they give you the plans to kind of like bring their thought processes to life, there are options for all. And, it's like, I always tell the kids now, it's like you're living in one of the most technologically advanced times in the history of ever. And so learning about this, finding your way, is just such a great thing. And I think, to me, that's the most interesting thing. We all have kind of like, it's, as you said, it's not linear. It's not like, oh, I started, knew where I was going to go. It's definitely a zigzag and around the mulberry bush. Let me ask you this. What's your why? What makes you get up every day and go, I want to go and make sure that we further space exploration? If you could cull it down to, what is your why, Jim?
I will answer that question, but permit me. You said something that's so important. You talk about the field of arts, and there's something. I have my own pet peeve. We call it STEM. Others call it STEAM because it includes art.
Mm-hmm.
And look, I've got scientists, I've got engineers, but I need Michelangelos. I need Leonardo da Vinci's. So I get chills saying that, but that's what it's going to take. This is about the dawn of a new era. And so we need to expand how we think about what we're going to do. So please keep that in mind as you're becoming that engineer or that scientist. The art side of your brain is just so important to really slingshot us forward.
And you know what? I love the Da Vinci reference. It's something that I have said for a long time. He let his art inform his science, and his science inform his art. And truly, that's one thing in education that I push for all the time. There needs to be an intersection of those fields. I think often what we do is like, oh, you're good at chorus and math, or chorus and drama and art and dance and band. You're in this bucket. You're good at this, this, and this. You're in this bucket. I was very fortunate to have some teachers along the way that were like, you're not exactly the best math student I've ever had, but you got a keen interest. So I was able to be that chorus, drama, band nerd that also loved her science. So I think that's why I also have great passion to make that an intersection, because I think that does expand what we're able to do as humanity. But now tell me why.
Honestly, it goes back to my mom. She lived to the ripe old age of 97. And when many years ago, I asked her, Mom, why are we here? Why are we on Earth? And she looked at me, and in one sentence, she said, Jim, we're really here to do the greatest good for the greatest number of people. And I think that wraps it up on how I think and what motivates me. I really even shouldn't be alive. And here I am. I'm the deputy NASA administrator. There's a plan out there. It's bigger than all of us. And if you can keep that in mind as you go forward, there are always hiccups in the road. And if you don't have a story, you will have one. And I just urge you to keep that in mind. You're part of that plan, and you just gotta sometimes take your hand off the wheel, and it'll go in the right direction.
Thank you. Thank you for those brilliant words. What a great way to get us started this morning. Continue to have a great day and inspiring those. My friend Melinda Benson always speaks so highly of you, and she's like, you guys have got to meet. You have a similar heart. So a pleasure to make the acquaintance this morning.
It's my honor. Thank you so much, Janet.
Thank you. Bless you as you go about your day. I love those comments by Jim saying that we must do, and the greatest work we can to all the people we can and all the places we can, as long as forever we can. And I would have adored your 97-year-old mom. That is for certain.